We're going to be starting talking about chapter 5, which is on exponential and logarithmic functions. The thing is, before we can actually talk about exponential and logarithmic functions, we have to do a little bit of background building first. Specifically, we need to talk about composition of functions and inverse functions. So let's start off talking about our composition of functions. So this is the definition of a composition of functions. Now, let's kind of get a picture of what's actually going on. Let's say that we have these three sets. Okay? And these three sets they are going to be a couple of things. Let's say that this set here is the domain of a function g. And let's say that this set is the range of a function g, which means that what we know is that g takes information from this set and moves it over to this set. Okay. Now, what if we had the same set that was the range of g? Let's say that same set was the domain of f, which then means that this set here we'll say is the range of f. So a function f takes information from this set to over here. So we have our function f and we have our function g. Now, what f of g does is f of g takes information from the domain of g and sends it to the range of f. This would be f of g. So essentially what happens is we take everything that's in the domain of g and send it to its range, because that's what g does. Here, the information then gets sent to the range of f, because that's what f does. So f of g is the composite, or the combination of both of them. A few things to note. This f of g has, like every function does, a domain and a range. Now, the range of f of g is a subset of the range of f. The domain of f of g is a subset of the domain of g. So we have these two aspects to where everything that's in our domain of f of g must be in the domain of g. And everything that is in the range of f of g must be in the range of f. Though this does not have to be the exact same as the range of g, or sorry, the domain of g, and this does not have to be the exact same thing as the range of f. So let's look at an example. And what we have here is function f given to us here, and function g given us to here. And we want to find f of g of 1, g of f of 1, f of negative 2, g of negative 1. Okay. So let's start off with f of g of 1. And what we need to do is we need to take this 1 and plug it into g. And then we take whatever that answer was and plug it into f. So let's do that. To find my f of g, I am first going to find what is g of 1. And g of 1 is 4 times 1 cubed plus 1, which is 5. And now that I have this value, I'm going to find what is f of 5. And that is 2 times 5 squared plus 3, which is 53. And what this tells me is that f of g of 1 equals 53. Let's do that with g of f. G of f of 1. So we take our 1 and we put it into f, and then we take that answer and we put it into g. So this is going to give us two possibilities, or two things that we need to do, I should say. F of 1 is 2 times 1 squared plus 3, which is 5. Okay. G of 5 is 4 times 5 cubed plus 1. Well, 5 cubed is 125. 125 times 4 is 500. So this equals 501. So this tells me that G of f of 1 is equal to 501. This is an important thing to note. F of g does not necessarily equal g of f. There are times that it does, but it does not have to. Okay, now let's talk about f of f. We're going to do f of negative 2. Well, we're going to do it the same way. We start off by taking negative 2 and we put that into f. And then we take whatever answer that is and put it back into f. So we have two things that we need to do. We have f of negative 2, which is 2 times negative 2 squared plus 3, which is 2 times negative 2, so I'll say negative 2 times negative 2 is 4, 4 times 2 is 8, 8 plus 3 is 11. And then we need to figure out what is f of 11. And f of 11 is 2 times 11 squared plus 3. Well, 11 squared is 121. 121 times 2 is 242. And 242 plus 3 is 245. So f of negative 2 is 245. And g of negative 1. So g of negative 1, again, this tells me that I put negative 1 into g, and then I take whatever that answer is, and I put that answer into g. So, two things. First, we have our g of negative 1, and g of negative 1 is 4 times negative 1 cubed plus 1, which equals negative 3. And then we have g of negative 3, which equals 4 times negative 3 cubed plus 1. Let's see, negative 3 cubed is negative 27. Negative 27 times 4 is negative 108. Negative 108 plus 1 is negative 107. So this tells me that g of negative 1 is negative 107. Okay, for this video we're only going to look at one more example, and then we will pick back up on compositions in the next video. But we have tables here. This is the table that's representing g of x. This is the table that's representing f of x. And this is the table that we're going to build that's f of g of x. Now, remember that f of g of x is telling me to take my x and put it into g, and then take that answer and put it in to f. So my x is negative 2, meaning I come to my g of x table. X negative 2 means that g of x is 4. I take that 4 and I look at my f of x, and I see that 4 takes me to 7. So f of g of negative 2 is equal to 7. Again, let's look at that. This negative 2 tells me to come over here and look at negative 2 in g. That gives me a 4. My 4 I put into f, which gives me a 7. F of g is 7. Now, negative 1, we're going to do the same basic thing. We're going to take our negative 1, and this time we are going to put it into, or we're going to still put it into g, but we're going to look at this negative 1. And negative 1 produces 1. 1 to 1 gives me 4. So f of g of negative 1 is 4. F of g of 0 is 3. F of g of 1 is 4. And f of g of 3. Let's look here. 3 is not in the domain of my x over of my function g over here. So I can't put this into G. There is nowhere for it to go. It comes over here, it looks, and then it gets confused because there's nowhere to put it, which means that this value is simply does not exist. Or another way of saying that is 3 is not in the domain of f of g. Okay, I hope that you are all staying safe, and I will see you.